Hello everyone, I'm Philippe ENTZMANN. I'm very glad to be here today having this talk about Python, transcripts, Json schemas, and the short story about the big form we have to handle in our project. I work at Aon as a data architect. We were working on a funny project where we have to handle very big forms, and I will show you the way we will handle some aspect of those forms, especially with transcript. I would like to thank Aon to let me having this talk today and tell you the experience we had with those technologies. I would like also to thank the University of Technology of Troyes, which is also involved in the project. So before diving into some tech details, let's have a bit of the context. Aon is mainly a broker, and one of their job is letting insurer to be reinsured. So basically they have to follow all in this case of the car insurer, they have to follow all the most important accidents and follow the expenses related to this accident, and be able at any time to say what the price of this accident and reevaluate the price of the reinsurance. So following this kind of accidents or injuries is doing with yearly evaluation over the whole lifespan of the victims. It means tracking the detailed expenses of physical and non-physical injuries to the victim and the relatives of the victims. We have also to make links with mortality tables, currency rates, and many other reference data. And a lot of this data is, I would say, structured, but very differently structured, and we have to collect all this data over the time. So we start from mainly written forms that have been previously filled, and the user have to input this data into the database. We work with MongoDB, but it doesn't really matter for the talk today. Different sources, different shapes that we have to consolidate in a single database. The data schema will highly evolve over time. This is very important feature. And our experts have to manage the data schema themselves. That's also a very important feature. They don't rely on administrator, DevOps, or whatever. They have to handle the schema themselves. So they have to add fields, nested fields, lists, set properties, and so on. They also have to split the whole schema in different reusable parts, because the schema will grow very, very large. And they also have to define simple but useful formulas. That's precisely this future that will involve us into the transcript Python implementation. A few numbers. Each form may be divided into up to 30 reusable subforms parts, leading to form with more than 300 base fields. And when the whole form is filled, you can have 1,000 fields filled up. So this is basically the architecture choice we made. Since we had to make this data inputs through a web forms, we have to choose a JavaScript library and do some front-end development. We choose to base our schema definition on the Json schema standard, and we choose the Json editor library written in JavaScript to handle the form part. One particular thing about this library is we basically use the schema to validate our data. That's a basic use of a JSON schema. But we also use the JSON schema to auto-generate the form, the full form. And this is done by the JavaScript library. So basically, everything is already done by those components, except one little thing. We have to write the business rules that we want to apply during the input on JavaScript, because that's the way you have to code on the browser. And by the way, when the form is filled, we get the JSON data representation that we can save in our Mongo database. Well, this first attempt worked quite well. You get here a small portion of the form. You get here the full screenshot of the form. You see how huge it is. We even have to make a plan with links on the left to help the user to jump on the right part of the form. So keep in mind that all of this form has been automatically generated from the JSON schema. And on this form, we add some fields that have to be calculated. We have some formulas defined and applied in JavaScript to handle all the forms. So it works. It worked. We still have some trouble with the JSON notation because we had our experts to write the JSON schema and handle it. So they are not developers, and they sometimes have trouble with the curly braces. They have to count them, open, close it, with a double quote. Very minor troubles, but still annoying. But we get much more trouble when we have to handle the business rules. Asking them to write this kind of code is definitely not an option. We try to have a very readable code, but it's very not easy to ask someone who is not a developer to handle that. So they barely try by copy-paste some existing code, but it was very not easy to handle. And for a single huge form, we have more than 3,000 lines of code of JavaScript that is definitely not usable for non-developer people. Okay, so the conclusion of this first attempt is, okay, don't ask them to handle this kind of business rule. It's definitely not an option, a viable option. So we try a second attempt. We keep our base technology path, and we just upgrade two things. The first one is only replacing the JSON format by a YAML one, much more readable, much more writable. It's quite easy. It has nothing to do with the transcript Python stuff, but very easy point to shoot at. The second one is rewrite the whole business rules from JavaScript to Python and integrates them directly in the JSON schema. And since we need this business rules to run on the browser, we had to use Python interpreter running in the browser called transcript. Okay, so here a very simple schema in a JSON form and in a YAML form. You see obviously the gain for an end user. And this one is a sample. They are not the kind of schema we are using, but this one is a real extract of our schemas. And you can see the JSON schema in a YAML form. And you can, I hope it's readable enough, you can see more extra field like calc, where you can find a formula. This is the way we expressed our business rules to be applied on different fields on the schema. There is another one on the right with also, I think I've got a laser pointer. I will try to. Okay. Okay, here you get the formula. Very basic ones, but very easy to write, very easy to handle from our experts. So now we can dive into the implementation. We just saw how we handled the problem and how we fix the trouble we first encountered in our first version. So we choose transcript, and we basically follow the steps to have our first experiment and second attempt to handle this trouble. So let's start with the setup. It's rather easy, the pip install, with some very obscure dependence with Java for the JavaScript minification via closure. The command to transpile the Python code to JavaScript is also quite easy. And then you just have to serve the static content generated. Okay, it has nothing to do there with Python. It's just a static server. The JavaScript has been generated and it can be run on any browser with any web server. So we then have to check that we can easily access the DOM, the document object model, and the JavaScript object. This is an extract of the transcript example. You can see on the HTML part here a click event that triggered a method greet that is exactly the one that we define on the Python code. And you can also see where it is part of our Python code that is accessing a document object model node by ID or by whatever you want to change. You get the ID, you change the HTML, and you put whatever you want in it. That's a very simple example, but to show you that it's rather easy to interact between the DOM, JavaScript object, and the Python code. Okay, the next thing we have to check is if we were able to call any function from Python to JavaScript and vice versa. Well, that's quite easy too. This is a Python code calling JavaScript reference that we already stored in self and calling the JavaScript method. And from the JavaScript part, the same thing, calling a Python method. So it's quite easy too. So at this point, we were very happy and was thinking, okay, that's quite nice. So let's just drop an eval of the formula string that we have in our JSON schema, and this should be done. But that was the first problem we encountered. The Python eval function is not implemented in transcript. It's clearly stated in the transcript project. They don't want to do transpilation on front end. You have to do this on the back end. So you can't call the Python eval function from transcript. So, okay, bad point, but parsing a string and having some reference to different fields and doing some basic arithmetic, it's not so hard. So we go on. For this, we have to do some Python trickery on dictionary object and using this kind of very magic method, but very useful ones. And surprisingly, it works like it worked in Python, in CPython. So we went we were very happy to be able to parse our formula. So that's the kind of formula we had. Very simple one with direct nearby field access. More complex one with dot notation to access, let's say, array subfields. So in this example, we have to do the times, the number times the amount, and then sum all the things. And we can even call some special Python function that the expert can define outside of the schema. So that's what it looks inside the schema. We didn't already develop this part, but it's just to tell you the kind of thing we were working on today. Having this very basic notation is fine, but when you get a huge schema and want to refer one field from another one at the opposite of the schema, you need some kind of relative positioning. And there is a very recent draft from the JSON schema group. They call this JSON pointer support with something like this. It's very weird when you read it the first time, but it's very powerful. You can, when you start from one object, that's the case here, you are here. Let's say you attach a formula to this part of your data. You can have this kind of notation to refer different fields relatively from your starting position. It even handles the array problem, because when you get some array, it's very difficult to keep the dot notation very, very clearly. Trust me, if you have a question about that, I can answer, but it's a very nice way to have relative field links. Okay, next step for us was to integrate this code into our PyTest environment. It was also nice. We doesn't have much related to transcript because in this case, we just wanted to have the same, to have run the same Python code, but in our PyTest environment, so without the browser. So we just have to write a kind of abstraction layer to have the same behavior with or without the browser, but it worked well. That's a very simple example of the test we can trigger. We load the schema, we load the data, and then we do some field value change and see what happened and check the results. That's a great way to develop without having the browser in the middle. But we also need to have end-to-end test with the browser. We already have this stack with Selenium and Splinter. Splinter, yes, very great abstraction library for using Selenium. So basically, we had exactly the same test that we run a second time, but this time the tests were run inside the browser with a transpiled version of this code. Okay, so great to integrate on CI job and so on. So smart debugging, I will only talk about that because that's the first things you check when you have to transpile a language to JavaScript. So it works nice, but we don't really use that. We prefer to put our time in the PyTest. It's better to work on the test rather than on the live debugging on the browser. But it works. You see when you get an exception. We don't have the console, but if you get the console, you will see the exception, and you get the exact line where the exception is raised. When you can't have source map, you can use a different approach provided by transcript. They can annotate all the JavaScript that is generated with the line number and the source code file path in the JavaScript. So when you get an error in the line, you can get back to your Python code. We don't use that neither. As I told, we prefer to use print statement directly to the browser console or inspecting a live object with the REPL console. Next thing we have to deal with is a transpilation process. We can't use static transpilation at the, let's say, at the commit time because our experts are able to change the formulas live in production server. So we have to set up a very simple transpilation step. We have to use this kind of tool that will check for on any file change and trigger a new transpilation. Okay, this is a quote from the transcript SIT stating about the overhead. They state that it's more 40 kilobytes over, and the speed is quite the same speed. So if you have questions on that, I could give you some more details, but we are very happy about the overhead in size and speed. Let's talk just a few seconds about the transcript alternative. We are not Python experts, so we were a bit lost about evaluating all these shiny alternatives. But to sum up, we definitely prefer the transpilation way because it's much simpler and you still understand what's happening. This kind of experiments are very nice, very promising, but for our case, definitely not ready for production. Okay, so to sum up, we were able to push Python in the browser, and it helps us to add new features to our automatically generated big forms. We avoid the usual two-language pitfall that that is very dangerous in this kind of project. And we close the gap between the front-end and back-end development that appeared when we tried our first version, which was heavily based on JavaScript. Just 2 more slides about the trend that is behind this experiment. It's not about putting Python everywhere. It's just that we still have the same problem. Whatever the project, whatever the team, everything is moving faster except your brain. And when you have to deal with a team, you have to have a common language or have something that you have to keep small and easy to learn and understand. So having Python on the browser is a way to avoid the fact that you can't master many programming language. You can't ask a non-developer to learn quite complex language. You have to set up a common programming language in your team to be able to communicate. And the 2 sets have to be very light and very easy to learn. So Python is, like many people tend to think, the current best answer to this problem. And just 1 slide from internal presentation. This is the way we split our stack. We have a visible part, something like anyone should not master, but at least understand. And we have a hidden part. We put everything in this part. It's only for the DevOps, but for the user and anyone in the team, even the sponsor, have to be aware of. You see the greater than sign. We don't ask anybody to master Panda or Plotly, but at least understand what a notebook is, what YAML is, what a test is, how we integrate in Excel, and so on. That's all. Thanks for your attention.